Earlier in the quarter, we showed you how to manipulate linear expressions. This is a linear expression. The highest power of x here is 1. Even if I distribute, simplify, combine like terms, and so on, I have a linear expression. The highest power of x is 1. Once we learned the different ways in which we could manipulate linear expressions, we introduced the linear equation. We introduced an equal sign, and we said that whatever you do to the left-hand side, you have to do to the right-hand side as well. Manipulation is one thing. I haven't changed the value of this side by distributing the 2. The 2 was already there. I just spread it out a little. Here, all I did was scoop all my x's into one big pile. I haven't changed the value of anything. So it's all still equal to 6. Now, though, to get the x by itself, I'm going to have to get this -2 out of the way. And then the 5 is in my way, so getting rid of that means dividing both sides by 5. My solution is x equals 8 over 5. But I only had a solution once I introduced this equal sign. Before I did that, all I could do was change the way the left-hand side looked. In fact, there was only a left-hand side. We couldn't talk about doing something to both sides before you saw the equal 6. Before this was here, this was all I could do. It was only after I introduced the equal 6 that I could go from this step and actually come up with a solution. But that's linear equations. What about quadratic equations? What are they? What's different about them? And how do we solve them? In Chapter 5, we learned how to build quadratic expressions. I took 2 linear expressions and multiplied them together. This gives me what's called a quadratic expression. It's quadratic because its highest power of x is 2. The whole expression is a quadratic expression. Then we spent some time factoring quadratic expressions by finding a product and a sum, rewriting the middle term, finding the greatest common factor of the first 2 and the last 2 terms, writing what was left over, finding the greatest common factor of these 2 big terms, and that's my answer. So this factors to this. Not surprising, since I built this from this. So all our work so far has been on quadratic expressions. What we're going to do now is learn how to solve quadratic equations. Let's go ahead and start with this one. In fact, let's go ahead and start with it already factored so that I can show you something. Before we start, let me make this observation. If I take 2 things and multiply them together, and the result turns out to be 0, then one of 2 things has to be true. Either A has to be 0 or B has to be 0. If A is 0, then I get 0 times B is 0. If B is 0, then A times 0 is 0, because 0 times anything is 0. Of course, they could both be 0. There are no other numbers that will do this for us. A times something equals 0 means the something has to be 0. It's the only way to get 0. We're going to use this property a lot in this section. Your textbook calls this the zero factor property. It's also sometimes called the zero product property, and I've heard it called the zero product principle. I'm only mentioning those because I'm used to calling it the zero product property, so you may hear me call it that. When I do, what I'm referring to is what your textbook calls the zero factor property. It's the same thing. If the product of 2 things is 0, a zero product, then that product has the property that one or the other, or both, of the things in the product has to be 0 in order for the result to be 0. All right, well, how does that help us here? This is a product, and its result is 0. So if I let this piece of my product, this factor, be represented by A, and this factor be represented by B, then either A or B or both must be equal to 0. So that means that either x minus 1 equals 0, because x minus 1 is A, or x plus 3 equals 0, because x plus 3 is B. And what I have now is two very simple linear equations, and I'm going to solve them separately. Adding 1 to both sides of this equation gives me x equals 1. Subtracting 3 from both sides of this equation gives me x equals negative 3. So which one's the answer? Well, my original problem said x minus 1 times x plus 3 equals 0. If x is 1, then this becomes 1 minus 1, which is 0. And 0 times anything is 0, so 1 works. If x is negative 3, then this becomes negative 3. Negative 3 minus 1 is negative 4. But if x is 3, then this is negative 3 also. And negative 3 plus 3 is 0. And I get 4 times 0. And 0 times anything is 0. So negative 3 also works. There are, in fact, two solutions to this equation. I could have given this problem to you in its unfactored form. I could have said, solve x squared plus 2x minus 3 equals 0. And ultimately, that's the kind of problem that you would need to use this on. But the way to get to the solution for this is to factor it. This is equal to 0, but this can be factored. It turns out that this factors to x minus 1 times x plus 3. Don't worry, we're going to do a lot more of these, and you'll see how that factoring process works again. My point here is to show you that given an equation in this form, if I can factor the expression on the left-hand side, then I have an easy way to figure out what my two solutions are. Each one of these has to be set to 0. And then I can solve. And that's what I've done over here, so I won't do it again. This is the same problem. It's just in this example, I gave it to you already factored. And in this example, the first step was to factor it so that we could use the zero product property. Let's try another one. For now, I'll start by just giving you problems that are already factored so we can see the zero product property at work. The factors x plus 3 and x plus 2, when multiplied, equals 0. Here's my A, and here's my B. They're multiplied, and their product equals 0. So either A equals 0 or B equals 0. Or both, of course. But A is all of this, x plus 3. So either x plus 3 equals 0 or B is all of x plus 2. So x plus 2 equals 0 is another possibility. Solving this one, I get x equals negative 3. And solving this one, I get x equals negative 2. Those are my two solutions. And I can check them. If x is negative 3, then I get negative 3 plus 3, which is 0. 0 times anything is 0. So that one's going to work. If x is negative 2, then plugging it in here shows me that negative 2 plus 2 is 0, and anything times 0 is 0. So negative 2 will work. Both of these are solutions to this equation. Here's another one. 4x minus 5 times x minus 6 equals 0. Either this equals 0 or this equals 0. And then I have two simple linear equations to solve. This one's really easy. Just add 6 to both sides. X equals 6 is one of my solutions. And I can check it really fast because if x is 6, this whole thing becomes 0. And 0 times anything is in fact 0. Solving this one's a little bit more involved, only because there are two steps. My other solution is 5 over 4. Harder to check, but not impossible. If I put 5 over 4 in here, I get 4 times 5 over 4 minus 5 in this set of parentheses. 4 times 5 over 4 is 5, and 5 minus 5 is 0. So this would become 0, and 0 times anything is in fact 0. So 5 over 4 also works. Have you seen a pattern yet? Have you noticed any shortcuts? Let's do another one and see if you can figure it out. If you know what I mean by finding a shortcut or seeing a pattern, then you may be able just to look at this one and know what your answers are going to be. And if you've got to that point, that's great. But let's work through it anyway. Not everyone will be there yet. And even if you are, this will give you an opportunity to verify that you know your shortcut's working. If this is my A, then A equals 0 is one of my solutions, or at least the first step in finding that solution. And this is my B, so B equals 0 is the first step in arriving at my second solution. Now I need to solve each of these. A equals negative 6 and A equals 1 are my two solutions. Plugging in negative 6 here will make this one 0. Plugging in positive 1 here will make this one 0. So both of these solutions work. Is that what you got if you used a shortcut? If your linear factors are very simple like this, you can just look at them and say, whatever the opposite of this number is, whatever the opposite of this number is, those will be my two solutions. The opposite of 6 is negative 6. The opposite of negative 1 is positive 1. Can you do that with one like this? Again, with some experience, you can. But also, again, let's go ahead and work through it. This one's also a little different in that it has another thing in front. This leading x hasn't been present in any of our previous examples. But it's still just a factor. It's still multiplied by the other two factors. We know the zero product property says that if A times B equals 0, then either A equals 0 or B equals 0 must be true. Would you agree that if I said A times B times C equals 0, that A equals 0, B equals 0, or C equals 0 must be true? In other words, this list can be as long as I need it to be, and each of the factors has the potential to be one of the things that must be 0. In this case, my factors are x, 2x plus 1, and x minus 5. It's the fact that it doesn't have a plus or a minus following it that throws most people off. Since x is just one of my factors, it's one of the things that I must set equal to 0 and then solve. Except there's nothing to solve. X equals 0 is one of my solutions. My next factor is 2x plus 1, so set that one equal to 0 as well. And the third factor is x minus 5. Setting each factor equal to 0 And then solving gives me my solutions. That one doesn't need solved because by setting it to 0, I found that the value x must be to make it true is 0. Solving this one gives me x equals negative 1/2. And solving this one gives me x equals 5. This isn't really a quadratic equation, but in factored form, each factor, as long as the right-hand side is 0, has the potential to reveal a solution. So in this case, we ended up with 3 solutions. I'll let you check these yourself this time. Okay, what if I give you something that looks like this, and I ask you to solve that equation? Well, the only way we have of doing that right now is by factoring the left-hand side and setting each of the factors equal to 0. In order to set the factors equal to 0, I need to know what they are. I have to factor this expression. Whatever work I do here, it's going to be equal to 0. Just like when we were learning how to work with linear expressions, and then I turned those into linear equations. So let's get started. How do you factor x squared minus 9x plus 20? Well, you find the product and the sum. The product is 20. The sum is negative 9. You find all the ways to write positive 20. Clearly, I'm only going to want products where both factors are negative. When I add these two together, I get negative 12. Here I get negative 9. There it is. That's the sum I wanted. So now I know how to break up my middle term. Negative 4x minus 5x. Greatest common factor here is x, and what's left over is x minus 4. Greatest common factor here is negative 5, and what's left over is x minus 4, because a negative times a negative gives me a positive. Greatest common factor here is x minus 4, and what's left over is x minus 5. So I've taken just the left-hand side of my equation, written it over here, and on scratch paper essentially, found a different way to write it. I can write x squared minus 9x plus 20 as x minus 4 times x minus 5. If I can do that, then I can essentially replace the left-hand side of my equation. But I can only replace the left-hand side. The right-hand side is still 0. This is critical. A lot of people forget to write this down. You're so caught up in getting the right factoring that you forget that you're solving an equation. We're just using factoring now as a tool. Do you remember the shortcut? These very simple linear equations tell me that the solutions are x equals 4 and x equals 5. Let's go back in case you're not quite ready for that. A times B equals 0 means either A equals 0 or B equals 0. Solving this gives me x equals 4, and solving this one gives me x equals 5. And that's what I got here. To check your answer, it might be a good idea to put it into the original equation. What if I factored it incorrectly? If x is 4, then this becomes 4 squared, which is 16. And 9 times 4 is 36, plus 20. 16 minus 36 is negative 20, and negative 20 plus 20 does in fact equal 0. So 4 works. What about 5? If I stick a 5 in there and in here, I get 5 squared, which is 25. 9 times 5 is 45, plus 20. 25 minus 45 is negative 20, and negative 20 plus 20 does in fact equal 0. So 5 also works. Not only have I found the solutions, but I also know that I must have factored it correctly. Talking around problems like this. But in fact, the process is a lot simpler. Let's do another one, and you can see what I mean. This is the cleanest possible version of a problem like this. Solve the equation 9x squared plus 12x plus 4 equals 0. Solving this equation means putting this side in its factored form. What is its factored form? My product is 36. My sum is 12. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6 are the different ways that you can write 36 as a product of two numbers. These add up to 37, 20, 15, 13, and 12. I'm looking for 12, and I'm finding it here, so these are the numbers I need to use to break up my middle term. Rewriting it, I get this. Greatest common factor here and here. And greatest common factor here and here. What's left over is 3x plus 2. This can be written like this. So I can replace the left-hand side of my equation with the same thing in its factored form. A times b equals 0 means either a equals 0 or b equals 0. In this case, they're both the same thing. There's no point in solving this equation all over again. I've just done it here. The result's going to be the same. X either equals negative 2/3 or it equals negative 2/3. Well, those are the same number. So in this case, my two solutions are the same. In some circles, we'll say that we have one solution with multiplicity 2. We have a second copy here. That's vocabulary you won't need until later on, but you will see it. You can either write this answer as x equals negative 2/3 or x equals negative 2/3, or you can just write the answer once, whichever you're more comfortable with. Just be aware that a lot of these problems do have two solutions. So make sure that if you're only writing one solution, that there really is only one solution. Working through this problem took me one single page. I did the whole thing on one screen. Here's my factoring scratch work, and here's the scratch work I needed to do the factoring scratch work. So this is all scratch paper. Everything in here supports the work I was doing over here. The actual problem, once I'd figured out how to factor it, really only took me a few lines. Okay, let's look at something else. Let's solve this one. A squared plus 25 equals 10a. This is a quadratic equation because the highest power of its variable is 2. But it's not equal to 0. So I can't use the zero product property. Actually, I can, but I need to use some algebra that I learned earlier in order to get it into a form that allows me to use the zero product property. Since what I need is for it to be equal to 0, let's get rid of everything on the right-hand side. If I subtract 10a from the right-hand side, I must also subtract 10a from the left-hand side of the equal sign. Now, my right-hand side is 0. My left-hand side looks like this. So there's a little bit of very early algebra coming back into play. The next step will be to get this into its factored form. Once the left-hand side is factored, it's still going to be equal to 0, and I can use the zero product property to finish the job. A squared minus 10a plus 25 factors like this. There's no greatest common factor. My product is 25. My sum is negative 10. My product is positive, so I either need to multiply two positive numbers together or two negative numbers together. Since my sum is negative, it's going to be this case. So my whole list is going to be made up of products of two negative numbers. Those are the only ways to write 25 as the product of two numbers where both numbers are negative. Their sums, negative 26 and negative 10. Here's the negative 10 I needed. So this is how I split up my middle term. Negative 5a minus 5a. GCF and GCF. Notice that this is a minus, even though this is a plus, because to get positive 25, I needed to multiply negative 5 times negative 5. GCF is a minus 5. What's left over is a minus 5. So this can be written like that, which means I can replace the left-hand side of my equation, a squared minus 10a plus 25, with its factored form. Now that I have that, I can take each of those factors and set it equal to 0. Here's another case where they're the same, so I only need to solve the equation once. Solving it twice would just be a waste of time. Of course I'm going to get the same answer, a equals 5. And that's my only solution in this case. Does it work? Well, replace a with 5 and see what happens. Replacing this a with 5 would mean 5 squared. That's 25. That's 50. Is that equal to 10 times a if a is 5 over here? Well, if a is 5, this becomes 10 times 5, which is 50. So the solution I found, a equals 5, works. Here's another one with only two terms on the left-hand side, but the right-hand side is already 0. So, since the only way we know how to solve these is by factoring the left-hand side, it looks like we're going to have a problem. We don't have a trinomial, so how do we factor it? Well, remember that the first step in factoring is always to factor out the greatest common factor. X squared minus 8x has a common factor of x, and if I factor that out, what's left is x minus 8. So that means that I can replace the left-hand side with its factored form. This is already as factored as I can make it. It's a linear factor, x to the 1, times another linear factor. So factoring out the greatest common factor is not only an essential step, it's the only step I need to take to get this in its factored form. Now, remember that just because it doesn't have a plus or minus following it, doesn't mean that x isn't a factor in its own right. This is a factor, and this is a factor. Things that are multiplied together are factors. So if each factor gets set equal to 0, I have my solutions. This one is x equals 0. This one needs a little extra work first, but it's x equals 8. My two solutions are x equals 0 and 8. And you can write that this way, or this way, or this way, or this way. Some of the questions in WAMAP will have an x equals and then a box for you to type your solutions into. And in that case, they need to take this form: a list of the solutions with commas between each one. So we know how to factor now, and we've learned how to solve quadratic equations by factoring the left-hand side. Here are a couple of things to keep in mind. First of all, make sure the right-hand side of your equation is 0. If it's not, you can't use the zero product property. Next, factor out the GCF. This is important for two reasons. One is that it makes the problem easier to factor. The other is that your GCF might actually be one of your solutions. That's mostly preparatory work. Ultimately, what we learned in this section was to factor the left-hand side, set each factor equal to 0, and solve the equations that result from this step. There are other ways to solve quadratic equations, and in fact, we'll learn at least one more at the very end of this quarter. Some quadratic expressions can't be factored, as we've seen, and you can still solve quadratic equations involving these quadratic expressions. But for now, we'll only solve quadratic equations where the quadratic expression can be factored. And that's it for this section. Ultimately, it's going to mean a lot more factoring practice. The last part, setting each factor to 0 and solving the small linear equations that result, is the easy part. Figuring out how to get your equation into that form is what takes the skill.